We are working on factoring higher degree polynomials. We have focused our chapter on factoring quadratic expressions, but for our 4.0, we will be factoring higher degree polynomials, so higher than second degree. So first, we always want to check for a GCF. So I'm looking at my coefficients first of 6, 46, and 60. Those are all divisible by 2. So then I move on and look at the variables. There's an x here. There's an x here. There is an x in all three terms. The least amount of times is once. So our greatest common factor is 2x. So I'm going to factor out the 2x, be dividing each term by 2x. And when I take 6x cubed divided by 2x, I would get 3x squared. And then 46x squared y divided by 2x would give me 23xy. And then 60xy squared divided by 2x would give us 30y squared. Next, I am going to factor by guess and check. So I'm going to start with my two sets of parentheses. The first terms have to multiply together to be 3x squared. So 3 is a prime number. There's only one option, so it's going to be 3x and x. Next, I move on to the last term, and I want the last terms to multiply together to be 30y squared. And I'm going to start with factors of 30 that are closest together. So I'm going to try 5y and 6y. So I also know that my signs have to be the same when I look at that last sign. And then I look to the middle sign and it's a plus. So they both have to be plus. So that was the guessing part. Now we check. My outside product here is 18xy. The inside product is 5xy, which does add up to 23xy. So now I have factored it completely. In number 2, if there's only two terms, we're going to ask ourselves, is it the difference of squares or is it a sum or difference of cubes? So we maybe are recognizing that 81 is a perfect square, 1 is also a perfect square, and then in this the variable part of this term, the exponent is even. So this is a perfect square and that is a perfect square. So remember that that factors into a sum and a difference of the square root of each term. So our first term's 9x squared times 9x squared. Last times last would give us minus 1. That outside product is a plus 9x and the inside product is a minus 9x squared, which would add up to 0x squared. So there is no x squared term here. So that when we distribute, it checks out. Now notice that one of our factors is a difference of squares. Again, 9x squared minus 1 is also the difference of squares. So anytime we have that pattern, we can factor further. So factoring completely means if you can factor again, you keep going. So the 9x squared minus 1 would factor into 3x plus 1, 3x minus 1, and then 9x squared plus 1 cannot be factored. We just bring that factor down. And in number 3, we're going to guess and check. So we have a fourth degree polynomial here, or a quartic, and we want the first terms to multiply together to be 3y to the fourth. We're going to split those evenly, 3y squared and y squared. Split the y's up. And then the last numbers have to multiply together to equal negative 28. So I'm going to guess negative 7 and plus 4. So that was a guess. Now I have to check. My outside product here is 12y squared. My inside product is negative 7y squared. 12y squared minus 7y squared does give me 5y squared. When there are 4 terms, we factor by grouping. So I'm going to look at these first 2 terms. What's their GCF? And that would be 9x squared. So I divide them by 9x squared. 9x cubed divided by 9x squared gives me x. 27x squared divided by 9x squared gives me 3. Then I look at the last 2 and ask myself, what is their GCF? And since this sign is negative, I have to factor out a negative. The greatest common factor between negative 4x minus 12 would be negative 4. So when I divide those both by negative 4, I would get x plus 3. So notice we have this common binomial here of x plus 3. That's our first factor. And then our GCFs, 9x squared minus 4, is the second factor. Now let's notice here, 9x squared minus 4 is the difference of squares. So again, we can factor further. So I just bring down my x plus 3. 9x squared minus 4 factors into 3x plus 2, 3x minus 2. So remember, difference of squares will factor into the sum and difference of the square roots of each term. Number 5, let's look for a GCF. Our coefficients are 20, 20, and 5. Those are all divisible by 5, and then there's also an x in each term, so I'm going to factor out a 5x. When I divide the first term by 5x, I'm going to get 4x squared. Dividing the second term by 5x, we get minus 4x. And dividing 5x by 5x gives us 1. I'm just going to guess and check here. So the first terms have to multiply together to be 4x squared. So I'm going to do 2x and 2x. The last terms have to multiply together to equal 1. And our signs have to be the same, and they both have to be minus. So I'm going to go minus 1, minus 1. Now I'm checking. My outside product is minus 2x. My inside product is minus 2x, which does add up to minus 4x. That's what we're going for. We know we have the correct answer. Now notice that 2x minus 1 times 2x minus 1, we have the same factor, so we would want to write that as squared. Okay, I should have added that. Now, number 6, what's the greatest common factor between these two terms? That would be 2x. If I factor out a 2x, I get 49x squared minus 36y squared, which is the difference of squares. So that factors into a sum and difference. With the square root of 49x squared is 7x. That's our first term. The square root of 36y squared would be 6y, and that's our second term.